On my left hand side are the three rules required to solve any question that has which has logs. So on this one here we have 7 raised to the power 2x plus 1, which is equal to 13. So to solve such a problem, you can take advantage of this rule. Remember, it's not possible to write 7 in terms of 13 or 13 in terms of 7 using natural numbers. So to do that, let's just apply this rule. So you can just use, we have two possible logs which are always available on your scientific calculators. We have this one, which is called the common log. This one has a base 10, and then we also have this one, ln or ln. This one is a log whose base is e, where e is some constant in mathematics. It's an irrational number, more like pi, but for now we can forget about the e. So you can either introduce this or this to both sides and then apply this rule. The rest is porridge. So I'll use this one. So you can introduce lg 2x plus 1 to both sides like this, and then after you do that, you can bring the power down using this rule. Remember, when you have a power like this, you can simply bring it down as a coefficient. So in a case where you have a polynomial or maybe a binomial or something that is like this, make sure that you put it in brackets. If you only have an n like this, then you may not need the brackets, but in this case you need the brackets, otherwise your work may not be correct. So now at this point you can either expand this and solve for x, or you can simply divide both sides by common log 7 like this, so that you have 2x plus 1 is equal to common log 13 divided by common log 13. So now at this point, I know a lot of students will mix the rules. We only apply this rule when you are subtracting the logs. It's not applicable. It's not true to say LG 13 over, which one? This one is supposed to be a 7 over LG 7 is the same as LG 13 minus 7. This is not correct. Make sure you take note of that. So now to solve for x, I can just bring the x to the other side, so that I have common log 13 over common log 7 minus 1. So now using your calculator, you can just punch this one separately and this one separately and then divide the two. Or you can use brackets and punch this one. Make sure you put this in brackets and then divided by this one in brackets too. Maybe you may not even need the brackets here, but I'll put them anyway. Yeah, so once you do it like this, you'll be able to get something like 1.3181. So I've just written it correct to 4 decimal places. And then now we can subtract these two numbers. So we have 2x, and this minus this will be 0.3181. And then dividing both sides by 2, your x will be, this will be a 0, then this will be a 1, remainder 1, that's a 5, remainder 1, into 18 we have a 9, no remainder, and then 0, 5. So your x will be approximately 0.159, like this. And you are done. You can even verify your answer by putting this one back in there. So because we have rounded off, you expect your this to be approximately, so if you were to substitute this in there, you expect it to be something like either 13.00 something something or 12.99 something something. Let's move on to the second problem. So for the second problem, we have something which is even easier but has more marks. So to do this, I can just take this one to the other side. So I can say log 2 x plus 2. I'll bring this log this side, and then I'll leave the 3 exactly where it is. And then I can apply this rule here, the third rule. Remember, when you are subtracting two logs, it's just the same as dividing their b and c. Yeah? So in this case, we have log 2. So that means I'll just divide this by that. So I can say 2x plus 2 divided by x, and then everything is equal to 3. And then at this point, by interpretation, we know that when you have log a of b is equal to c, then you can convert this from log form to exponential form by saying a to the power c is equal to b. Remember, this thing here means to what power should I raise a to get a b? And that power is c. So to what power should I raise a? The power is c to get b. So I'm getting a b. So we can just apply the same rule here. To what power should I raise a 2 to get this? The power is 3. So we have 2 to the power 3 to get x plus 2 over x. And then when I find the cube of this will be like 2 times 2 times 2, which is an 8. This is equal to this. And then we can cross multiply. You can write a 1 there if you want. So I have an 8x, and then an x plus a 2. Then I can bring the x this side, and then we have a 2 there. So this minus this is 7x, which is equal to 2. I divide both sides by 2, and my x, or maybe your x, is equal to 2 over 7, and this solves the problem.